So for this question, we need to think about two parts. The first part is where a particle is at the bottom and comes up 60 centimeters. So that's our first part. And our second part is when it goes above 60 centimeters up to this top distance here, and we'll call this part 2. So we need SUVATs for both. And the first thing to think about is the velocity of my particle. So the velocity of my particle at the bottom here is 0 meters per second because it's at rest. Here we don't know, so let's call it v meters per second. And then at the top, where it instantaneously comes to rest, it's 0 again. Okay, so we go from 0 to v and then back to 0. What we also need to think about is between here and here, we have a different acceleration to here. Okay, so I'll call this acceleration A1 and I'll call this acceleration A2. Okay, we'll put an arrow in this direction. So let's look at this first section then. So if we write down our SUVAT and decide what we have. So we have the distance. The distance is 0.6 meters. We have the initial velocity, which is 0. We have the final velocity, which is v. The acceleration we'll write as a, and the time is 0.51 seconds. Okay, so if we just want to find v, we actually don't need to worry about the acceleration. We can use the SUVAT s equals u plus v over 2 times t, and we can think about this and rearrange it in order to find what v is. So we know that u is 0, so that disappears. So we end up with s equals v over 2 t. So to rearrange for v, times by 2 and divide by t. So we get 2s over t. Okay, so to find v, let's put some numbers in. S is 60, so we times that by 2, so I get 1.2 meters, divided by the time, which is 0.51 seconds, and this gives me a velocity of 2.35 meters per second to the minus 1. Okay, so that is the velocity at this point here. Okay, so for part 2, we need to think about this velocity 2.35 becomes 0. We know what this acceleration is here. Because I've removed the force, this acceleration A2 must equal minus 9.8, or gravity. So the acceleration is minus 9.8. Okay, so again, if I write out my whole SUVAT list, S is what I'm trying to find. U is this initial velocity here, which is v, so that's 2.35. V is 0 now, because it comes to rest, and our acceleration is minus 9.8. Don't need to worry about t, okay, because that's not part of the question. So we're going to use v squared equals u squared plus 2as. And we know one of these is 0. So we know that the v squared is 0. So if we rearrange this, we're going to get minus u squared over 2a, and that's going to give me my distance s. So if I put some numbers to this, I'm going to have minus 2.35 squared. Now, the negatives might go a bit funny here, but don't worry about it. It's only negative because I've brought it over to this side. So 2a is going to be minus 19.6. So if I do 2.35 squared divided by 19.6, the negatives should cancel out. Essentially, this negative is outside of bracket. Okay, so if I do that, I get S is 0.286 meters. So that gives me in centimeters, because we started with centimeters, 28.6 centimeters. So the particle travels up 60 centimeters. When I remove the force, it travels a further 28.6. Okay, so the total distance of the highest point from the lowest point is going to be 88.6 centimeters. Okay, have a think about that question and see how you get on. Try it again yourself. This is quite a common concept in mechanics questions where you have a force which is removed and we need to use SUVATs in 2 stages. Okay, any questions on this? Just ask.